Hi everybody, this is an intro video for Series and Parallel Circuits Lab. So it's Series and Parallel Circuits PNW, and it looks something like this. And we're dealing with a couple of experiments, a series circuit and a parallel circuit. So take a look through this, read through this introduction part, and you'll make some predictions. It talks a little bit about how to measure current and how to measure voltage. So remember, to measure current, you've got to put the meter in line with the circuit, and to measure voltage across the resistor or any circuit element, you put the voltmeter across, or across means around it like this. So to measure current, you've got to put the meter actually in the circuit. So you've got to break the circuit and put the meter in. More about that in just a minute. So in the lab, you'll make some predictions, and then later on you'll revisit those predictions and see if they were right or not. So what's the relationship between voltage across the resistor in series? You'll have to refer back to the chapter for that. What's the relationship between current through each resistor in series? So series and parallel circuits behave differently. So take a look back through at that. This is just your prediction. You'll get credit for whatever you put here, but make sure try to answer the question correctly. Okay, and then after you get your answer in, you'll have to hit submit to go on to the next part. I've already done that, so I don't have to do that again. And then resistors in series. So we're going to construct a circuit using this circuit Phet. So if you click here, so I'm just hovering over Circuit Construction Kit, click on it, and it opens up this Phet here. So Phet means Physics Educational Technology. And there's a few things here. Let's go with conventional current, so I can hit conventional current. Really, electrons are moving the opposite way of conventional current, but we'll go with conventional current. And I can click values here. Here's a whole bunch of circuit elements I could use. If I want to do it symbolically, I can hit here and these all become symbols. Here's what they actually look like. So wires, batteries, light bulbs, resistors, even have a switch here, fuse, paperclip, money, coins, erasers. I believe there's even like a dog down here. Oh, maybe not. Okay, there used to be. Pencil wire, all these different things you can use to build the circuit. We won't use them all, we'll just use some of them. Okay, so I'm going to switch this over to this view, and then we can build a circuit. The first one is to actually build a series circuit. So I could grab a battery. So I've just let's see. I left-clicked it, and I could move it over here, and you could grab it, move it around. Now, if I click on this thing, so I've just clicked on the battery, I could change the value of it. I think we're supposed to be at like 10 volts. And then I could add whatever circuit elements I want. So I'm just clicking on this one, dragging it over. I can attach it here. I can grab a resistor, so I'm just clicking on it, moving it over. I can grab another wire. It's a lot quicker to do this in this format than it is in the actual lab. Grab another wire, move it over here, grab another one, and I'm just grabbing the end and I can stretch it out. And then if I want, I can grab another one just to make it look nice. And then to change these, so you can see conventional current flowing, I can click on this 10 ohm resistor and change the value. I think it's supposed to be 15 maybe. There's the slider here. Okay, pretty good. Click on that one, which I believe is supposed to be 25. Okay, good. So I've got this current flowing through this circuit. Now I can measure the voltage across these different components by this voltmeter. So I'm just clicking on it, and I could drag it over here. So I think they want you to measure the voltage across this resistor 1, which is the 15 ohm. So the way that this works, you've got to put this lead over here, put this lead over here. You get 3.75 volts. So that's the voltage drop across this 3.75. Now if I were to switch these, it's just giving me the opposite, negative 3.75. So if current's flowing this way, you put the the red lead, which is the positive side here, and the negative one over here. And then I can get the voltage drop across this resistor by doing this. The voltage drop across both of them. So now I'm going from here all the way over to there. 10 volts. Hopefully that makes sense. The battery's providing 10 volts. It's being used up here. And I can get the voltage across this battery too by just going across the battery. And it should be 10 volts. And it is. Okay, so that's the Phet construction kit, and it tells you to build that circuit, this one here, and then measure these different voltages. So I showed you how to do that. V1 is just the voltage across the first resistor. V2, voltage across the second. V12 is the voltage across both of those. Okay, and then you could give the readings here. So like V1 is equal to. So I can type V, and then here's a little subscript. And then I can do 1. And now I'm done with subscript, so I can hit that button again. That goes away. Equals, and then whatever it was. I think it was 3.75. I'll leave that part to you. And then this says to upload a screenshot of your previous step when you measured V12. So how could you do that? A couple of ways. I've got this snipping tool. I could use that. On my computer, it's just here. So I could do new. So if you're doing this on campus, you'll have access to this too. Although I want to get it across both of those, so let me go back to this. They wanted V12. So that's across the whole thing. So let me go back to the snipping tool, new, and then something like that. And then I could do edit, copy, and then I could just go back to the. Then I can go back to the Phet. To the actual lab, and I could just click in here, and then Control V to paste. And then it's right there. Another way of doing it, I'm going to click on this and do backspace. Another way is to let's go back here. You can take a screenshot of this by going down here to these 3 dots, screenshot, and now that's saved it into the my downloads. So I could go back to here then, and there's a little thing here, this insert picture or insert image, and then go to wherever you saved it. Circuit construction kit. And then I can hit update, and it appears that way. So a couple of ways of doing it, however you want to do it. Okay, I just wanted to show you how you can do that. Okay, what's the algebraic relationship between V1, V2, and V12? As you saw, this one plus that one gave you this one. That's what it means by algebraic relationship. V1 plus V2 is equal to V12. Okay, remove the voltmeter and then measure these different currents. Insert 3 ammeters. So how do you do that? Let me take this away. And I want to break the circuit and put these different ammeters in. Let me make sure where we want them here. Between this one, before that one, between them, and then after. Okay. So I can click here. Cut. I can move these things around. And then I could take an ammeter. Ammeter means it's measuring the amperage, and put it there. I didn't quite connect it. You can see those don't overlap. Okay, good. Same thing, I can break this circuit here. And I might have to scoot things around a little bit. And then you could take another ammeter. So now there's a broken circuit. There's no current flowing. But I could take this one and put it in here. Whoops. Okay, good. Same thing, you could break the circuit here, and then put another ammeter in here. So essentially, we've got the same circuit. This one doesn't look as pretty as the one on the lab, but it's the same idea. This is just one continuous series circuit. Okay, so that's how you could measure the current. Let's go back to the pivot. Okay, 3 ammeters to measure the current, and then you want to make your measurements and record them here. And then take a screenshot, upload it. And then algebraic relationship between 1, 2, and 3. Well, you saw they're all equal to each other. Okay, and then I don't want to give you too much information here. So does this make sense based on your predictions from before? Okay, and then a little calculation here. Calculate R2 using your measured values of voltage, current, and voltage. How does the calculated resistance compare to the value you got? So you could use Ohm's law here. V is equal to IR, so V over I would give you R. So it's verifying that the resistor value is correct. So whatever the voltage was across V2 divided by the current through, the voltage across R2 divided by the current through R2, that should give you the resistance. So you should get the same thing as the actual resistor value. Okay, so a little exploration with that. So a similar thing with resistors in parallel, you just have to build a different circuit. It has to look something like that. So now in a parallel circuit, current comes out of the battery. Now it has two choices. It could go this way or it could go this way. Remember, wires for our purposes in this experiment don't have any resistance. So I could make this wire and this wire the same length. Just because this wire is longer than this wire here doesn't mean it has more resistance. Okay, so if current's coming this way, 15 ohms versus 25 ohms, more current's going to flow through the path that has less resistance. Not because it's closer to the battery, just because it has less resistance. Okay, so same idea. I don't want to go through all of these. It's similar to what you did in the first part. It's just a different circuit that you're using this on. Okay, and then finally, there's a discussion part here where it's sort of a summary of what you've just learned. Okay, have some fun with it. You don't have to make any graphs or anything like that. This one's all about building circuits, measuring voltage, measuring current, using a little bit of Ohm's law, and hopefully by the end of the lab you'll be able to tell the difference between series circuits and parallel circuits. If you have any questions, just shoot me an email and I'll talk to you soon. Bye-bye.